Successful crush. Timeout. And a successful read of the barcode, but an unaccepted crush.
You're going to want to get closer.
Almost this way.
Yeah.
Is everybody in?
Yep, now you're
All right.
good.
Not that close.
I'm sorry.
Everybody in? So
Yeah.
Are we in?
Now you're good.
My name is Dylan Degree.
My name's Evan Planky.
I'm Stephen Barada. And we're here to present our senior project, the Pneumatic Can Crusher. Basic concept behind it is we input the can through this input Rolodex. We use a Hall effect sensor to detect whether the input Rolodex is open or closed. The can drops into our crushing area. Use a proximity sensor to sense the can. Once it's sensed, we scan the can using a barcode reader. If the UPC is accepted, then we'll crush it. If we do not accept the barcode, then we'll reject it down through this chute right here. And if we can't read the barcode, it'll also time out and shoot down the reject chute.
So what we can do is we can present a little demo for you guys. So this would be the state for a timeout, meaning it will try to read the barcode, but it will not be successful, and it will time out after 4 seconds, dispensing it through the bottom, uncrushed. Perfect.
Success.
And this is a successful scan, but the incorrect type of can.
So this will dispense as well. There we go, finally read.
And this is scanning, barcode, and a can that we will crush.
Perfect.
Perfect.
So we can go through the bits and pieces of the project a little bit more in detail now.
You guys walk through the electrical design concept.
So see if you want to go ahead and talk about the electrical.
Sure. What we have up here is a 24-volt power distribution board. It's using optically isolated solid-state relays. And what this does is it allows us to control the 24 volts that we need to operate our solenoids using a 5-volt microcontroller. And the microcontroller is an ATmega 328, which has our own custom program on it, which is a finite state machine program.
So I'll go through a little about the sensors. So like I said in the intro, we use a Hall effect sensor to detect whether our input Rolodex is open or closed. That function is basically just on a magnetic field presence, and it switches to states. We use a infrared proximity sensor to sense the can. Basically puts that at 0 when the can is detected. Right up here is our barcode reader, which we actually use to read the UPC codes. And we also use two sensors, magnetic sensors on the cylinder, so we can tell whether that thing is open or closed, or reject or extend state. So, if you want to finish up with the mechanical design.
Alright, so in order to actually crush the can and maintain the integrity of the system all in one unit here, what we came up with was we didn't really want the can being pinned up against the wall. We wanted the force being in a contained unit. So what we did here for our crushing assembly, it is actually tied together with threaded rods so that when the can presses up against the crushing plate on the other side, all the force is contained within the unit. Helps for structural integrity. What we also did is safety was also important to us in this design, so we designed an input assembly such that when you go to input the can, it is impossible to get your hand caught in this thing while the system is running at the same time. That is also due in part to the Hall effect sensors that were mentioned previously. You see, can goes in, program won't even turn on based on the position of the Hall effect sensors, and just by the sheer shape of the input roller provides an added safety in addition to the electronic safety that is included in the system as well. That's it for the mechanical, for the most part.
That's it. Thank you for watching.
Thank you.